Hi, I'm Selva Prabhakaran. In this one, let's understand the Poisson distribution with an example very clearly. So, what we will do is, we will take a problem statement. We'll take an example problem. We will solve that problem first using binomial distribution. Using binomial distribution first. Okay, we will solve it completely. Then we will see how this can be applied and solved using Poisson distribution itself, so that you are able to see the connect between and the transition between going from a binomial distribution to a Poisson distribution. Okay, so this is the problem. It's based on an ads click example. People run ads online, right? You have Google ads, Facebook ads, and so many different types of ads online. Let's say you have a given ad unit. Okay, so for that ad unit, on an average, you get 2 clicks per 1,000 views. 2 clicks per 1,000 views on an average. Now, this ad is shown to 1,000 visitors per day. To keep it simple, we are keeping just 1,000 visitors for this one. Assuming this to be the case, what is the probability of getting 4 clicks the very next day? Okay, so this is the problem. We want to know, we are having a certain ad unit and that ad unit is getting 2 clicks for every 1,000 views. Now, what is the probability of getting 4 clicks the very next day? So the next day, for any given day, we are showing it for the next 1,000 views. What is the probability of getting 4 clicks? This is the problem. Okay, so on an average, this is getting 2 clicks a day or 2 clicks per 1,000 views. Both are equal. Every day we are getting 1,000 views in this case. Okay, on an average, it's getting 2 clicks. What is the probability of getting 4 clicks? That is the whole problem statement. Now, this sounds like a binomial distribution problem and it can be solved using binomial distribution. So let's solve it first. The success, let's define success. Success is getting a click. Like all binomial distribution problems, we will define success first, which is getting a click. So we are showing this ad to so many visitors, so many viewers. If you get a click, that is a success. Probability of success we know, which is 2 clicks for every 1,000 views. So this translates to 0.002. Now we want to know for the next 1,000 views, what is the probability of getting 4 clicks? Let's solve this. Okay, so we want to know probability of getting k, n given probability p, right? So we write this, we translate this probability of getting 4 clicks for 1,000 views, 1,000 trials, 1,000 views, given the probability of success to be 0.002. This is solvable, right? We have seen the formula for this using binomial distribution. If you have not watched the binomial distribution lesson, please go and watch that. It's fairly simple. All we need to know to apply this right now is this formula. So NCK, probability P of probability of success, P power K, 1 minus P power N minus K, which translates to, so N here is 1,000, C4, probability P here is 0.002, here we have multiplication, this power K is 4, right? And multiply this by 1 minus 0.002, this raised to the power 1,000 minus 4. Okay, so N minus K. Now, if you solve this, I will write the answers directly. I have already done this using calculator. You can do it using Python. If you use Python, you will need to import math. You have already seen this. Import math. And then we use the function math.comb, right? And pass in 1,000, 4. You will be able to get the answer to this part. Okay, then you can multiply this and get the final answer. Now, the final answer to this. So alternative, if you want to do it by hand, you will do it something like 1,000 multiplied by 999 multiplied by 998 multiplied by 997 by 4 into 3 into 2 into 1. Okay, so if you want to do it by hand, you can do it this way. So I have already solved this and the answer to this is 9.02%. Likewise, similarly, let's also do one more calculation. The probability of getting 2 successes of 1,000 trials, that is 2 clicks of 1,000 trials, 1,000 views, given the probability of a click to be 0.002. If this is the case, we will get the probability to be 27.09%. Remember these two values. These are the calculations or results we get by using binomial distribution. Let's now solve this problem. Let's now connect this to how we would solve it using Poisson distribution. Now let's see how to solve it using Poisson distribution. So if you want to use it, Poisson distribution has a rate parameter called lambda. Okay, so in our case, the lambda value works out to be 2 clicks per 1000 views, right? So that would turn out to be 0.002. That would be the value of lambda in this formula. So by the way, this formula is the probability mass function for Poisson distribution, because Poisson distribution deals with discrete values. This is a discrete probability distribution. You cannot have continuous values. You cannot have the number of events to occur in decimals, right? So this is a discrete probability distribution. Now this has one important rate parameter lambda, and we know this value. Now given this lambda, given this rate, if we want to find out what is the probability of, say, 2 clicks occurring for every 1000 views or 4 clicks occurring for every 1000 views, considering the rate parameter to be the constant throughout, that this value does not change, considering that to be the factor, we can use Poisson distribution. We can use Poisson distribution to actually calculate this particular probability. So the probability of getting 4 clicks, given the fact that we know that we are getting 2 clicks for every 1000 views, right? So this is the rate parameter. Given this rate, if we are getting clicks at this particular rate, what is the probability of getting 4 clicks on any given day, right? In this case, we don't have to worry about the n parameter that we had seen in binomial distribution. Okay, there's no concept of number of trials. So given this, we can substitute k and lambda into this equation, into this whole equation. We substitute it and we get the output, the resulting probability to be 9.022%. This is the exact percentage that we got using binomial distribution. Remember this formula, we got this particular answer using binomial distribution. Likewise, if we want to get k equal to the number of clicks to be 2 clicks for 1000 views, we substitute k equal to 2 and keeping lambda to be the same as the last time. We substitute in the equation and we get the answer as 0.2706. The answers will match exactly with what we have got with binomial distribution. So in a nutshell, we can use Poisson distribution. When to use Poisson distribution? If we know that the events are occurring at a constant rate lambda. For example, say in a call center, you are receiving 100 calls per hour. Okay, this is the average lambda rate. This is the average rate at which you are receiving calls. Now you want to know what is the probability of receiving, say, 150 calls in the next hour, given lambda equal to 100, right? So k equals to 150, given lambda equal to 100. If you want to know this probability, then you can use the Poisson distribution to compute it. Okay, you would simply substitute 100 lambda power k, lambda power 150, multiplied by e power lambda, e power minus 100, divided by k factorial. So k is 150 divided by 150 factorial. You calculate this. That would be the probability of getting 100 calls in the next 1 hour. Hope that makes sense. So we understood Poisson distribution using an example. In the next one, we will approach the whole concept of Poisson distribution in a more formal way. We will do that so that you are familiar with the theory, conceptual, and application standpoint also. See you in the next one.